Could you please tell me what are the agentic AI architectures we could have? Many of you have faced this question in recent time interviews. Hey everyone, this is Abhishek. So today I am going to talk about various agentic architectures that we can implement in our project. In any agentic AI project, we could think of three layers of planning beforehand. First thing is like how the workflow would work, the orchestration layer. Second thing is like how a particular agent would do the reasoning, the thought, the planning. And the third is how a single agent would call the tools, or maybe multiple agents would call the tools. So one is like how the workflow, how the reasoning, how the tool calling. So based on that, we can plan our agent. Okay. So first we would talk about the reasoning or thinking pattern of architecture design. So for that we would go a little down, and here you could see four types of like reasoning pattern we can have, the architecture we can have. Okay, so first of all, like let's say one agent had to do well defined steps of thinking or action, then the chain of thought would be the best suited. Here what would happen, like when an input would come, first one prompt we would generate. With the prompt engineering, LLM call would happen, we would get the response. With that response we would create another level of prompt that would again get go into the LLM and would get the answer, and at the end we would get the final answer. Okay, so like here actually example I have given, like when something problematic happen, like take get the symptom, uh, what is the cause, find it, what is the policy about that cause, find it and get the resolution and done. Like it's a straightforward thing. There is no here and there thinking. Okay, I mean, like there is no condition. So let's say a agent would have several ways to solve it. Okay, in that case tree of thought would be the best suited. So here would have what would happen, like one input would come, there would be three four whatever, like multiple ways of solve it. So you could call everything, all the agents. It would get actually it's not agent, it would thoughts or the LLM calls, and whichever would give the best result, we would take that. If something fails, we would not take that output, we would just get the best result, and that would be the answer. Okay, so now these are very straightforward things. Now let's say we have first I would talk about the self refining. So in this case, or in this case, let's say one LLM call need to be revised. Okay, then the self refine architecture would be best fitted. What would happen, like draft means input, critic means the actual the LLM call to get it, another LLM call maybe, or some condition would be there to check the output is perfect or not. If not perfect, again do another round of what's LLM call or thinking or planning. Okay, and then again get the result until we are satisfied. In the revise stage, we would do the calling of the LLM, and at the end we would get the final answer. Done. Okay, so like here I also given an example, like draft execution summary, like some revision work, if there we can have. And another thing, like here where the tree of thought would be best fitted, like uh, straightforward, like rack kind of, rack plus react kind of things, we can go for the tree of thought. What is rag and what is react, we would check in the below we have. Okay, we can go after some time. Okay, so now the last thing is like graph of thought. So graph of thought means it's like one input would come. So from, let's say, from the top some input comes into this box, it would go and thought everything. Like all the ways we have, we would do the LLM call. would get back the result. The best result we have, we can go, do a feedback loop, like same thing what we do here. It's a advanced version of this self refining, where multiple LLMs or multiple prompt engineering would work. Okay, so thought means like one properly engineered prompt with a LLM call. So it would go and it would check and it would get the data, and when it's like satisfied, it would get the result. So this is much of it, like how the based on the thinking pattern, these are the four ways mostly in the market we use. Okay, so next we would go for the tool calling. Okay, best. So in tool calling we have lot of different ways. Let's say, yeah, let me come here. So here this is the layer 2 tool calling architectures. So here we have React, Pelpot, Rag, plan and solve. So plan and solve is very simple kind of thing, but mostly what actually in the market we use React and Rag is mostly used in various projects. Okay, so let's talk about the React first, maybe. So let's say one input comes. Okay, we would first thought, would take a action. Take a action means that actual tool calling. Would do the tool calling, would observe it. Observe means like what we did as revise, or I mean like checking like the result is perfect or not. If not good, again thought, again action. In thought there could be multiple thing. I mean like this is tool calling way. So here you can add any of these four ways to think. So in thought, we could have a linear thought, we could have a tree of thought, we could have a graph of thought, or self-refining in the thought. This four architecture is based on how the tool calling would happen. So action means the tool calling. Okay, so so this is happened like when the thought is perfect, then we would get the final result. Okay, this is React. So it's called like reasoning first, then act, then observe, then reasoning, then act. Act means tool call, then observe, then again reasoning, and the final answer. Okay, this how the React things come works. So mostly like coding, auto coding kind of things, React is very good kind of way to do. So Palpot is like a particular logic implementation or particular thing you want to do. You know there is only in single shot you would get the answer, and it's a it's well defined specific thing. So let's say one input comes, you came to next level, you could call multiple tasks or action or tool call, then you would get the final result. So this is like plan and solve. So how it's like, you do first plan, and then like first something you would get, then you plan, then you decide like which one to do, or multiple things you can do, and you gather the answer, and like okay, done. Now come to the Rag is a very widely used. Most of you might already have implemented this in various projects. So how it's happened, most people mostly know. So I would go through once. Like you get a document, mainly it's like retrieval and like you retrieve a data, and then you augment it, then you generate the result. Okay, so let's say you got multiple docs, you chunks it into various chunking methods are there. Then you embed it. Embedding you get from the LLM, you store those embeddings into a vector DB. Then when a query comes, the user query comes like give me this particular thing, and it would search all the goal is to search the whole document and get the particular answer with some generation. So that query comes, it retrieves the best k values. K means like how many best values you want to get from vector db. You get it, you re-rank it. Sometimes re-ranks don't you need or not, you have to decide it. Mostly we re-rank it for better answering. then you actually after that you do the prompt engineering with the re-rank data from the whatever data you got from vector db, or on based on that you create the prompt properly, you call the llm generates the answer. So this is pretty much the rag. In later some videos I can create some more videos on rag, where I would implement rag properly, maybe that I could do. Actually some years back I have created one video also in with I mean like how to implement rag with langchain. You can check my other videos, you can get that. So this is pretty much about the tool calling. So we have this four ways of doing the tool calling. Now coming to the multi-agent architecture. So it's this is actually the architecture, how your agentic architecture, multi-agent architecture would work. Okay, so router pattern is simple, like a request come, then you decide like which agent to call. So this each and every agent would be built by any of these four reasoning pattern and any of these four tool calling pattern. Okay, so each agent, so here we are just orchestrating the agents. Okay, so it's pretty much simple. uh, Again, like the question comes, you decide here, here we decide like which agent to call and we just call it. In orchestrator, like again, like you call multiple agents and you get the answer, and you I mean like combine it into a single answer, you provide the answer. Okay, now mostly like this is very tough to implement and very works very well kind of, but tough to implement, I must say. So here what would happen, like one issue or one problem statement comes to the agentic multi-agent architecture. Here it comes. Now it decide like which agent to call. Maybe this agent, it's I mean, like for code generation kind of stuff, complex code generation kind of stuff, these are very good, like where you do coding with this maybe, then checking with this maybe, uh, this agent maybe. Then maybe you add some css, you for this with this agent you do html with this agent, maybe some javascript with this agent, and this agent maybe test the whole code. So if any issue comes, here it comes and again it calls. I mean like back and forth, like these are works with one another. Okay, each agent is responsible to do a single particular thing, and this event bus is actually managing all the things. Okay, so it's called choreograph, peer to peer. Now in competitive debate, like this is like again simple thing, not very tough. There are a lot of agent, you just judge it which one is best, you take that answer and just answer it. Okay, like it's simple like this. Here we are taking all the answer, here just we are taking only single answer. It's the this judge agent is the very crucial in this architecture. Okay, so this is pretty much so in below I have mentioned all the things. It's best use cases you can go through. I have very precisely choose this use cases. So yeah, that's the thing. And here some questions also I have actually these I have generated with AI. Like you can go through this question answer. Actually I mean like I have generated this with AI, but I have checked like these are very important for interview purpose or these days. So you can go each and every question. Maybe I would add some more detailed question, maybe some tough implementation level question use case I can give, like yeah. So this is pretty much in this video. So if you like this video, give a like, maybe you can subscribe if you things like this type of videos you want in your future. And yeah, thanks, bye bye.
वीडियो पसंद आए तो लाइक कीजिए और ऐसे ही इंफॉर्मेटिव वीडियोस के लिए चैनल को सब्सक्राइब कीजिए।